All right. With this first presenter, Deepesh Majumdar. Sir, you are present. I can see that. Deepesh Majumdar, sir, will be presenting on numerical study of an I-plan shaped building under wind excitation. So please share your slide and go ahead.
Yes, I'm just sharing. Okay, I'm sharing. Thank you.
Okay, sir.
Whether my screen is shared? Anybody, please?
Yes, sir. Please
Okay, thank
start.
you. Thank you. My name is Dr. Deepesh Majumdar. I'm assistant professor of Jalapur University. I'm here to study our paper, numerical study of an I-shaped building under wind excitations. First of all, I must convey in this particular stage that although I'm a professor, but contribution of this paper is majority should be given to my student. His name is Kitam Shaha, and he's a very enthusiastic, and he has done the majority of study of this particular numerical analysis based paper. This is our basic things that from our end. An outline of this particular uh, presentations, the introduction, computational modeling, numerical study, and in the numerical study, we'll discuss about the boundary condition and computational domain, simulation cases. There's a two different cases we have studied over there. One is square plate plan shaped building and another I plan shaped building. Then we studied the validation of the result, and finally we have concluded. So this is the basic outline of our presentation today. Now, first of all, I will discuss some introduction part. In civil engineering structures is a nowadays we are having a great challenge everywhere because these kind of highly hazardous load like earthquake, wind, and fire related load are day by day increasing. As you know, this especially this tropical cyclone, the intensity of tropical cyclone is day by day increasing, and it is especially for Eastern India for last 5 years we are having intensity and the frequency of the tropical cyclone is increasing, and at the same time we are constructing a very different and complex shape of different type of building nowadays in India. So these two things are creating a very great challenge for us. Now, how to mitigate this type of challenge? That is a big issue, and for this particular paper or particular research, we have done and we have tried to study how wind load may be very crucial for a particular complex shape of a building. That study we have done it in this particular paper, and that already I have conveyed that the complex shape of the building is a big issue. At the same time, intensity and frequency of the tropical cyclone is increasing, especially in the eastern India and in this Bay of Bengal. And another cause of this increment of the intensity and frequency is due to global warming, and complex shape of the building is the main cause. Is that most of the architect nowadays they are designing a building in such a way so that the specific area or surface area of the building with respect to the volume of the building is day by day increasing, because to make the building more energy efficient or natural ventilation, to create more natural ventilations. So complex shapes are nowadays almost a inevitable part of uh, building structures. So every civil engineer or structural engineer facing challenge uh, this type of uh, 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 this type of challenge, two two different challenge they are facing, as well as the load is increasing or frequency is increasing at the same times. The complex shape of the building is creating great challenge to them. And at the same time, as you know, the non-structural elements or glazings, these different type of glazing like glass window facades become a very vulnerable part, and that we have seen in last Amphan in Kolkata. It was really hazardous, and all the various buildings has faced this kind of uh, hazard due to very high intensity of wind. And although it was properly designed and fabricated, but still various kind of failure was noticed and reported in various parts of Kolkata. So that's why you have taken this project to study what is the main cause, right? And this is our very two simple model we have chosen during our study. First of all, we have chosen a simple square shaped building in plan, and as a model study. And at the same time, we have chosen another complex building in compare with a I-shaped building. And for simplifications, we have reduced the in a scale in 1 is to 300. And as you know, this computational domain, as per Frank's model or Frank model, that overall boundary conditions, we make it in such a way, or we proposed it in such a model it in such a way. In a downstream, it is 15 to h is the height of the building, and in upstream it is 5h, and sideway it is 5h, and upward it's also 5h. So actual the total height of our total domain become 5h plus h, total 6h. So this is our overall computational domain that we have taken into consideration during our computational process. And this is a diagrammatic representation of our basic mesh. And as you know, generally it is a very common to reduce the overall computational cost or time, generally to produce more good data along the interface. The mesh is more dense, and far from the interface, the overall mesh density become less. And this is the plan building, and this is the I-mesh building, right? And for velocity, we reduce it is to 1:5 is a very common, and for the dimensional, we reduce it up to 1:300. This is the simulation case we have considered. For the wind, there is a 3 different angle of incidence we have considered. One is 0, 30 degree, and 45 degree. For square plane and I plane, there is another extra. It is coming for 0, 30, 45, and 90. As 0 and 90 is same for the square plane. So that we have not considered. I plane 90 degrees extra we have considered. And that is the different phase that we have mentioned over there, A, B, C, D. And here it is a different phase, and that surface, it will be needed to understand the different pressure diagram that I will show you in my discussion, right? And whatever numerical result we have produced in our numerical analysis, that analysis we have done K epsilon model, and that analysis, this computer CFD analysis we have done with ANSYS, right? And to match with the actual result, whatever value it is given or it is provided on IS 875 part 3, whether our model is working or not, or whatever our assumption is correct or not, we match it, right? And this is our the value that whatever our meshing and whatever our assumptions, that we match it, and this is the property, this is the value that we match it. And the windward side, the surface coefficient, our work is around 0.79, and this is total permission is 0.8, and this is the value that we match it on the numerical package, and which is very impressive. So far we have done it, and after that we our further result we noted, and we proceed. And this is the sum of the outcomes. Definitely, due to time constraint, I'm not discussing all the outcomes over there. In a nutshell, I'm just showing you some of the outcomes of our small this project. Yeah, you can see the wind is coming from the right side of the building. This is our building, right? In a plan I'm showing, and definitely this is the turbulence that it is over there, and this is the static pressure contour. And in static pressure contour, you can notice over there, in a whenever the pressure, wind is hitting over there, and this is the pressure contour, definitely for 0 degree this windward direction surface, the pressure is highest, and definitely in the other surface, pressure is definitely it is reducing, and there is a negative pressure is creating, and in the junction area there is positive and negative pressure drop, is it is highly noticeable. And another very important thing that you can notice over there, at the top, due to some local eddies or local vortex, some at the just top, some area you can notice, some area, some negative pressure is creating at the windward portion, right, at the just top, at the top. And this is the other surface which is showing the different pressure control, right? This is a very common, and I believe everybody is very aware of this. But now the real picture that I want to share, what is the major outcomes that we noticed in our small project, that is in this one, right? This is very important. So this is a I-shaped building, right? When we'll talk about the I-shaped building in result and discussion portion, whenever the wind is coming along this just 0 degree, you can notice just downstream portions, there is a lot of vortex, and here small eddies and vortex they are creating. And this is whenever it is 30 degree, there is a huge difference. You can notice over there, see a very localized vortex it's creating over there. Yeah, I got it. Localized vortex is creating over there, right? And 90 degree also, 45 degree also. So 30 and 45 degree you can notice over there, and you can notice it on my next diagram, which is very important, right? See, 0 and 90 degree is very common, and it is almost matching with the same criteria, same diagram that I have shown you, like this static pressure diagram of 0 degree. But now, if you notice on the 30 and 45 degree, these two are really very is a remarkable difference with respect to 0 to 90 degree, that you can notice over there. Here, whenever the wind is hitting on this particular from the right side directions, in this particular area, there is a huge plus or positive pressure you can notice. But in just opposite direction, there is a negative pressure diagram you can notice. So that positive and negative, definitely it will create a huge torsional effect on the building for both 30 and 45-degree angle of incidence, which is a very noticeable findings or result that we notice. And at the same time, we believe we are working further, and we are in the same wind pressure diagram. We are creating a structural modeling on the basis of this particular wind pressure diagram. And I believe this particular pressure diagram that we are doing some computational work, how much extra torsion is creating over that particular structure that we are computing, and that is very much considerable, which cannot be catered by common factor which is given in our code or formatted in our code. So definitely in a conclusion, I must convey for different complex shape, the computational fluid dynamics or wind tunnel test is a mandatory process to find out or to design a structure, make it safe, and that is the thing I must convey at the end. And the same thing. This is the in a plan, and in a pressure control. You can notice over there. See, in a particular 30 and 45-degree angle, you can notice in this particular surface here that it is a positive, and the same thing in other side it is a negative. So that positive and negative pressure is maybe very vulnerable for this kind of complex shape building. So that thing I must convey over there. Thank you, and I'm here to answer any question. And I believe I made it within time, ma'am. Thank you.
Any questions, anyone? Thank you, sir, for a very informative presentation. It seems like a very exciting research field.
Thank you.
And I would like to congratulate your undergraduate student as well for doing an extraordinary work.
Thank you, ma'am.
Any questions from the audience? You may unmute yourself and ask the question. Anil, sir,
No,
do
I
you have
have a
any
question.
question? Yes, sir.
Okay.
Please go ahead, sir. Anil, sir, are you here?
Yeah, yes, sir. Actually, I have only one question. And am I
Please,
audible?
please.
Right.
Yes, Mr. Kumar,
So,
please, you can ask.
sir, wind structure interaction. This is a wind structure interaction problem, right?
Yeah.
So, which software have you used, sir, to
ANSYS,
simulate the study? ANSYS, right, sir.
ANSYS.
So, actually, the formulation that we use for wind,
Yes.
I think it's a Lagrangian formulation.
Yes.
So, am I correct, sir?
K
Which formulation
epsilon.
is it?
Gitam, are you here?
Yes, yes.
Yes, a KFCL and terminals
K
model.
epsilon. This model we have used over there.
Okay, sir. Right.
It is written in our paper. I have not shown. If you are interested, I can show you this basic equation.
Mhm. No, that's all right, sir. Fine.
Okay.
So, have you considered the percentage of opening? I mean, there is obviously some permeability in the structure.
No. In this particular paper, Mr. Kumar, we have not considered any kind of opening over there, because definitely you are absolutely right. Whenever the real structure is going to maybe some opening, but at the same time, as you know, nowadays most of the structure, high-rise structure especially, we are constructing with the structural glazing, like 2 or 3 different layer of structural glazing. So most of the case openings are very less, but definitely for this particular study, we have not considered any kind of opening over there. That I must convey in this particular platform.
Right. So the other factors that can be considered, I think, are
Yeah, that can be considered. Definitely, there is an option in this particular modeling strategy, ANSYS. There is an option, but in this particular paper, we have not considered. You are absolutely right. I must.
surface texture, or you say
Yes,
surface
yes.
profile, that can
Yeah,
also
yeah,
be
yeah, yeah.
incorporated.
Opening, maybe opening. There is
Effect,
options. The opening, there is options. There is options. We
effect
can
of
create.
adjoining. So have you considered the effect of adjoining buildings as well, sir? No.
No, here we have not considered. It is, I have clearly mentioned, is a single building with 5H, and top
Okay.
is a 5H, and the downstream there is a 15H. That's all. We have not considered. And definitely in a real life, that adjoining building, if there is a building over there, all this has to be considered. But the
Right.
particular this case study, we have not considered any kind of building.
Right. Well, sir,
Right, sir?
thank you. Okay, that's all, sir. Thank you. Thank you.
Thank you. Thank you. It's a very basic word, but definitely, if you can start with the word, we can add different factors. Right. You're absolutely right.
Yes.
Okay, sir. Thank you.
Sir, I had a couple of questions. If you can share your slide, show your presentation.
Yeah.
Sir, I was wondering about
In
the
a
plan of the building.
plan. This one.
Yes,
Are
sir.
you comfortable?
Yes, sir. Yes, sir. So the dimensions of the I building is about 300 by 250. The total height and flange, and the square building is 100 by 100. Is there a factor where
Yeah, 300. One is to
it
300 that I have already mentioned.
yes. So is there a difference? So that's the difference between due to the dimensions of the structure.
No. That real structure is 300 time of the original, whatever dimension you have shown over there. You have reduced it.
Oh, okay.
You have
You have
reduced it.
scaled it down.
Yeah.
No, actually, I wanted to ask the relative dimensions of the two plans you have considered. Uh,
Okay.
like ABCD is 100 by 100, and height is same as
Yes,
far as
height
I
is
know.
same. Height is same. Height is same.
And the square dimension or rectangle dimension of I plan is different. So, is there an effect due to this, like the difference due to this change, or that dimension change is insignificant?
Actually, our basic motto is to notice the pattern. Right?
Okay.
If you see, we basically wanted to find out the basic pressure diagram, basic creation of the vortex, like that, right? The actual value, definitely it will change with the changes of the dimensions, right? So basic shape, how the shape is going to affecting the overall what I should say, soil structure interactive pattern. That's why I believe these particular dimension in this particular case is not going to affect in so much, right? Uh,
Okay, so from the vortex, I guess your conclusion would be that we can find out the torsional effect on the
yes,
building,
yes, yes, yes,
and then the torsion effect will affect the response.
yes. That's it. A secondary paper we are just working over there like that.
Okay,
Okay.
thank you, thank you, sir. If there are no other questions, thank you very much, sir.
Thank you.
You may stop presenting. I will call upon the next presenter, Dr. S.P. Srinivas Pedala. He will be presenting on buffer sizing in construction scheduling using critical chain project management. So you may present your slides.
Sure. I think Deepesh sir has to uh, I think it is still sharing. I think Deepesh's screen is still on. Yes, to disconnect, right? I mean, you should stop presenting it. Then only I can.
Deepesh sir, you may stop presenting. Stop sharing your slides.
It is showing here. Deepesh Majumdar is presenting. That's it. Can I share? Shall I? Will it
Yeah, I think you can share. You can
Okay,
still
sure,
share.
sure.
Please try sharing.
Okay, it will remove. I think his automatically.
Yeah.
So can you see the screen, ma'am?
Yes, sir.
Okay. Thank you. I will start my presentation. So good afternoon, everyone. This is my second paper in this conference. And this is the title of my presentation, Buffer Sizing in Construction Scheduling Using Critical Change Project Management. And myself, SP Srinivas Padal, I'm a presenter. And my co-authors are Divakar L and Vijay Kumar P. So we are from Rama University of Applied Sciences, Department of Civil Engineering, and we are specialized in construction management. So generally, if you talk about any construction projects, we have different views of stakeholders. I mean, every stakeholder will have different view: architectural design, structural design, plumbing design, then till construction. Everyone will be working in the isolation basically. So how to connect this is very important because everyone is working for common goal. So proper scheduling is very important. Scheduling actually takes one of the critical success factor for completing a project, with good profits, in a given time. So we required always a better scheduling. So scheduling is all generally scheduling is nothing but planning your task on day by day, or just you have to show how you're going to complete a project. For example, if I talk about any project like building projects and all, then what happens is you need to identify a set of activities, like maybe there are 300 400 activities will be there to complete a project, and you have to arrange in a sequence manner in some sequence. That is called scheduling. And we all know that's critical path method. I think even in BTech also have learned in elective course CPM. It is in short form. It is called CPM. It is one of the widely used project schedule technique, but it has one of the main limitation, which is nothing but overestimation of duration. So CCPM is another technique. It's most advanced, like a critical change project management. It is mainly developed from a manufacturing sector. So that's why I want to just explore like how it can be useful in construction industry also, because it focuses on minimum duration. Like it helps us to minimize the project duration by taking safety buffers. So what I mean is it will typically avoid the human behavior errors, like over human behavior, student synchrome, Parkinson law, everything can be avoided basically, which generally happens in CPM schedules. So just for explanation, you can see this. So the first one is the conventional project schedule. It is called CPM, and you will see that if you talk about any project, let's say we have 4 activities or 4 jobs to be done. Let's say excavation of the building, concreting or reinforcement fixing. Then what is next? You can have anything like a concreting also. You can have. Then you can have finishing work. So you have 4 activities to be considered. And you see that generally what happens, we always take some extra days. Let's say I can complete this job in 5 days only, but still I will take some 2 days or 3 days more, because there is always some sort of uncertainty is there. There is always a some risk will be involved in the project, so we have to take some additional buffer. So, but again, we don't highlight that additional thing. We don't highlight this safety buffer, or I can say that extra duration, which is not required actually. That is called nothing but task buffers. Whereas in CCPM, critical change project management, we remove all these buffers and we compress this project schedule duration. Then we add all this buffer in the end only, not in the middle, between the activities. And we will make it explicit. So stakeholders, project managers, construction engineers, clients, they will come to know, okay, this is my project buffer or safety buffer, you can say. So what happened, instead of focusing on entire project like this, we focus only on this red point, still here only. So we plan to complete a project within this time. So it means we are actually reducing the project. But again, in reality, still the project can be extended, but still again, we will be using this buffer. But even after consuming all the buffer, we will be completing the project in the right time. That's all about CCPM technique. But it's so there is not only just a buffer in the end, but we also have buffers in the between, which I will show with example. So this literature review revealed that there is a lack of structured methodology to include or monitor buffers in construction schedule. So the object of the study is to develop a framework, again to develop a methodology to incorporate these buffers and monitor these buffers in a project. So we talk about this buffer sizing, and because when I talk about buffers, we need to estimate the size of the buffer. So if you see the simple project network, scheduling network, and you see this 2, 6, 8 is a critical activity, And end of the critical activity, or in terms of critical chain, we have project buffer. PB is nothing but a project buffer. We also use feeding buffer, which actually links the non-critical and critical activity. This red one is a very, in layman language, these 2, 6, 8 are very critical. I mean, if you delay this, if you delay these activities, and your entire project will get delay. But whereas if you delay this 1 and 4 activity, or 3, 5, 7 activities, it will not delay the entire project. So these feeding buffers will actually monitor. It will help us to, it will show the progress of non-critical activities, so that in the event of any some conflicts, we can rearrange. And there are different types of methods are there: cut and paste method, root square error method, adaptive procedure with this one, density method, then adaptive procedure with resource tightness method is there. And out of all these methods, I have selected root square error method because it doesn't uses the any rule of thumb, whereas other methods uses some rule of thumb. So if you talk about example, if you take the same example, I've just explained how to calculate the buffer size for feeding buffer and project buffer. For any activity, we have to take 2 durations. One is a safe duration, then you have to take aggressive duration. Aggressive means it's a minimum time, basically. Aggressive or risky, I mean, which safe duration means it has all the possible errors and all. We assume some errors may happen. We assume some uncertainty may happen, like that. We assume many things and we add on safe duration. Whereas aggressive duration is we assume that nothing is going to happen and nothing wrong going to happen. That is aggressive duration. So in this root square method, we generally take the difference between the aggressive and or safe duration and aggressive duration, which is nothing but a root of sum of squares of difference between the lowest duration and aggressive duration for each activity. For example, if I talk about project buffer, we take 2, 6, 8 activity. 2 here is there, 9 minus 6 whole square. Then 6 again, 6 minus 4 whole square. Then 8, 3 minus 2 whole square. And I have to give a square root. So using this method, we can actually quantify the buffer size. So here the units are nothing but days. It can be anything. It can be hours. It can be days. Let's say it is days. I'm taking it as days. Then it will be days. Similarly, feeding buffer also, you have to estimate in the same manner. This is how the buffer sizing is done. And this is not enough. Just by estimating the buffer sizes and reducing the project duration, it's not enough. You have to do some simulations before you start the project. So in this too, as I told you again, we always in construction industry or construction projects are always uncertain in nature. So to quantify the uncertainty, I had taken low uncertainty, medium uncertainty, and high uncertainty in terms of sigma, basically. Nothing but standard deviation. And we also conducted some statistical measures like goodness of fit test. Then we also use some software because Agile CC is one of the software where you can incorporate buffers. This software primarily developed for manufacturing industry, and we adapted for a construction industry also. Then we also use some other software like Easy Fit software, Random Gen software, Riscon software, mainly for generating random numbers, for generating random activity duration within the given range. So this is a proposed methodology to insert or to implement this CCM concept. So initially you have to develop the construction schedule, then you have to estimate the project buffer and feeding buffer. Then you have to reschedule actually. Then what happens, you need to check before you start monitoring the project, you have to check whether this feeding buffers creating any conflicts. If not, if it's creating, then you have to remove that part of the buffer and you add it on the project buffer in the end. If it is no conflicts, then you can identify the uncertainty and random activity durations can be generated and you can do simulations. If you can also check the number of simulations. Let's say we have taken this small project as 100 runs. You can also take 50, you can also take 200. So you can keep on trying, you can keep on do some iterations till we arrive best value. Once you do simulations, you can analyze the buffers, you can check what is the buffer consumption, we can also check what is the progress of the schedule. So to implement this concept, we have you have chosen this case study. It's a basically welfare housing project in Chennai. It's a G+10 building. And initially what we've done is we have actually built a original schedule in MS project. You can see that it's a 816 days project. So we have just loaded all the time, this is a sequence basically. This is nothing but a schedule. We also loaded the resources to determine the cost. And we also use Agile CC software. Mainly in this software, what we can do is we can also implant the buffers. All the buffers can be planted in this. That's the best part of this. And we quantified. So all the buffer will have to be estimated manually only. But we can import, once it is estimated, we can import this Agile CC software. It will show the reduced duration. So once we estimate the duration, we've done some simulation runs and we try to understand how this feeding buffer is consumed. As you can see in this particular column, we have changed it in different dates. You can see power. It's a simulation only. I mean, you can see the dates are given. It is not yet happened. I mean, it's just forecasting. So you can see as 0% consumption, this is the progress of the work. 30% of work is completed, and you see that 74% of the feeding buffer consumption, 31% completed. This is for feeding buffer. And similarly for project buffer also, we just tracked for different percentages, and we also track the project completion days. So as the feeding buffer is consumed, our project completion should also happen. I mean, our project should be completed before entire feeding is consumed. That's the logic. Let's say if you see this diagram, from this you will understand what I'm trying to say. On the, this is called fever chart. You can see on the x-axis it is a critical change completed, it is given. In layman language, it is nothing but our project completion, percentage project completion. On the left hand side, you have buffer consumed, which are safety buffers, which I explained to you. Now what is happening here? There are three zones are there: green, yellow, and red. So green means we are actually in safe direction. I mean, safe means we are executing the project in normal way. If the data goes to the, this line goes to the red zone, it means that you are consuming all the buffer before you completing the project. So if you can see this curve, I already plotted a curve using the simulation data. You can see this. It's a pretty linear. I mean, this critical change completed and buffer consumption going in linear direction, and it is in green zone only. And even by seeing this line only, you'll understand this. You can see the green border, how where it is ending. And by the time you complete your project, 100% project is done. At that time, you can complete your, you can consume all your buffer. So it is safe only. The main idea is we should not consume the buffer before you complete the project. You can consume all the buffer. By the time you consume all the buffer, your project should be completed. That's the logic. So this is how we can monitor the schedules basically. So we also done across the different uncertainties, like I explained above, like 0.1 uncertainty, 0.3 uncertainty, then 0.5 uncertainty. And we are done, actually we compared project duration with different uncertainty and with different buffers, like 10% buffer, 30% buffer, 50% buffer, like that. And we found that at a low uncertainty, we can reduce the duration, whereas as compared to 0.3 and 0.5 uncertainty. That's the one of the key finding, because as the consumption of buffer increases, we can actually, our progress also will become better. But again, there is not much change in uncertainty 0.3 and our medium uncertainty and high uncertainty. So again, if a project is very high uncertainty, then the buffers, when you cannot actually, the buffer management will not work much. I mean, that's what I understood. If the project is having little like a low to medium, then we can actually use buffer pretty well. So the community discussion. So again, the case study revealed that CPM methodology has a potential to minimize the project duration by managing the buffer systematically. And root square method is one of the powerful technique for buffer sizing. And you can also see that for 0.1 uncertainty, there are different confidence intervals are generated. For example, 842 to 849 days. And you can see that basically for 50% RB, duration is decreased a little bit compared to the no buffer. But whereas for 0.3 and 0.5, there is not much difference. I mean, you can see that at zero, no buffer, it is 853 to 883 days. Whereas at the 50% buffer, it is 830 to 859 days. So what I'm trying to explain is, as the buffer consumption increases, the project duration will decrease basically. That's the idea. So to conclude, what I can say is project scheduling is very important. It's essential for timely completion of any projects, not only in construction industry, but any industry we take, project scheduling plays a major role. So in this study, we developed a methodology to implement the CCM concept in construction projects. So, and again, as I told you before, CCM is one of the potential technique because it will generate the accurate scheduling by considering the buffers. Unlike traditional technique where we add safety buffers in hidden manner, we actually put all the buffers in the end of the project or end of the non-critical activity. That's the best part in CCPM. But again, it is not a decision-making tool. It will not give data like that. I mean, it will give some results, and using this concept, we'll get some data again. But you have to use, you have to interpret the data in based on your project again. So it only supports the, it is not a decision-making tool, but it will support decision-making with necessary information. So as I told in previous presentation also, accurate information is very important. Accurate input to the project should be given. That is very important than any other thing. Like you can use different techniques. You can use some more mathematical or high-end softwares or high-end analytical techniques, but still, if the information is not correct, if the input is not correct, then we cannot, I mean, this concept will not work better. That's what about CCPM. It will give the accurate or necessary information to the construction industries. So these are my references. These are critical, some of the important references I showing in the slide. And so I want to conclude with this presentation. Again, I want to thank this conference committee members and also examiners, reviewers who reviewed our paper, and also the conference chairs for who are evaluating the current presentation. And this is my contact. So if any questions, I mean, if you want to collaborate in future also, anyone can, I mean, even I also want to collaborate. So we can have any discussions in the future also. Thank you.
Thank you, sir. It was a very informative presentation. Are there any questions from the audience? Please unmute yourself and ask your question. Anil sir, any questions?
No question.
Ask you.
Yes.
This project scheduling depends on the list of tasks or list of tasks that you have to perform during a project, which is
Yes.
decided in the planning phase,
Yes.
like
Right.
tendering and all of that phase.
Yes.
Now, how do anyone doing the project monitoring incorporate anything like finance problem in the middle of the project or
Hmm.
snags or things like that?
Yeah.
Is there a provision for that in the
Yeah, that's what. Yeah. So this buffer concept is that only buffer takes care of all type of problems, such as that's what we keep. If we have any suddenly like COVID came, project is delayed by 3 months, let's say. So this buffer will take care of that delay. Or if any
Okay.
financial problems also comes, like cash and all, like cash flow is not good suddenly, contract has to change the project, or maybe the client wanted to change the contractor and all. So all sort of no uncertainties like that, delays, financial issues, even quality issues, everything can be taken care of by buffer. That's the idea of buffer. It's like a
Okay.
safety buffer which is added to the end of the project, so you can use it if required.
So, but then the follow-up question is, when you
Yes.
were calculating buffer,
Mhm.
I thought that was based on the existing activities.
Yeah, yes, existing
So,
activities, that is correct.
so if
Yeah.
we calculate that based on existing
Uh-huh.
activities, what is the provision to
Yeah,
account
I
for
understand.
such major
Yeah, that's what
delays?
traditionally what happens. You can see it is written here: safe duration and exit duration. So safe duration is nothing but what you're saying when we take all the uncertainties for each activity. Whereas we have another one called aggressive duration, where we do assume that there is no problem with the project. We will not have any problem. So this buffer size, when you actually calculate the buffer size, there are two data is there. You can see that we take the difference between the low risky duration to high aggressive duration. So what is happening is that there are two data are there. One data is which without any issues. I mean, another data we have with a set of problems. So we're taking the difference between these two, so that the problem which you are telling that will be taken care in the end of the project as a project buffer.
All right. So, I mean, I see you have incorporated for uncertainties as
Yes,
well.
yes,
So it would be more of a probabilistic
right.
scheduling in a way.
Right. Probabilistic is
Okay.
probabilistic only. That's why, like I said here, like if you can see here, I given there are range, right? It's a 6 to 9. Activity
Right.
2 starts from 6 days to 9 days. So we have that range. So that's why I had simulated to quantify that uncertainty. Again, we use normal log normal distribution only, which is equivalent to triangle distribution to quantify the
Okay.
uncertainty.
Okay, sir. Are there any other questions from the audience? All right. Thank you, sir.
Thank you. Thank you very much.
With this, I will call upon the next presenter. I don't think Kirutika R is present. So we will move on to the next paper, 373. Mr. Shreyas Pranav, are you ready with your presentation?
Yes, ma'am.
All right. So please start presenting while I introduce you. Mr. Shreyas Pranav will be presenting next paper on a feasibility study on the potential usage of engineered cementitious composites in Indian pavements. Please start your presentation.
Thank you so much. So our paper is titled "A Feasibility Study on the Potential Uses of ECC in Indian Pavements or Engineered Cementitious Composites," and it is paper written by Mr. Sahil Taka, Dr. Mukund Lahoti, and myself, and I'll be presenting it today. So, starting with the introduction. So, so when I say feasibility of ECC as a pavement material, what I mean is specifically to look at the life cycle cost aspect and the material properties aspect, and like sort of compare it to other alternatives available in India and across the world also. So, just a brief introduction about ECC. ECC is a special category of fiber reinforced composite, and typically PVA fiber or polyvinyl alcohol fibers are used. And
Uh,
yes,
Shreya sir, I think your presentation is not moving. Please come out of the presentation mode and just
oh, I'm sorry.
present as it.
Visible now?
Yes, yes.
Okay. So, so as I was saying, when I say feasibility of ECC as a pavement material, it means primarily in this study, in this particular study, it primarily means from a life cycle cost and material properties perspective, and sort of compare it to other alternatives available in India and across the world. So, a brief introduction about ECC. ECC is a special category of fiber reinforced composite, and typically fiber is a PVA fiber or polyvinyl alcohol fiber. And its unique characteristic is that it possesses exceptionally high tensile ductility, and for that reason, it is sometimes known as bendable concrete as well. Um, and of course, when I say concrete, it does not have coarse aggregates, but it is still colloquially known as bendable concrete. So here you can see a picture of flexural test being performed on an ECC beam. So it possesses that unique tensile ductility, and it is close to hundreds of times more than concrete. So that is its unique characteristic. So coming to the need of this new material in pavements. So first of all, I'm talking about what are the problems in existing pavement materials. So when it comes to asphalt, we all know that it comes from petroleum, and petroleum reserves are fast dwindling. And according to many world energy reviews, it is not expected to last more than 50 years. And also, we have our own personal experience that asphalt pavements are very much prone to distresses, cracking, potholes, and so on. And so the natural alternative is concrete, but in concrete as well, there are other issues like it typically has to be made using joints, and because of its low ductility and because of the stresses that appear in the concrete pavements. So joints, when as soon as we talk of joints, there is the problem of material ingress into joints and acid attack or something like that, and joint spalling, pumping, and so on. So, and also both these types of pavements have, because of these reasons, lot of uh, requirement of repairs, and they also have a very low service life, close to 20 to 30 years approximately. In fact, asphalt pavements can be even lower than 20 years sometimes. So, our proposition is to offer a material which gives a higher service life and lower requirement of repairs with high durability. So, specifically talking about ECC, first of all, ECC, as you must be knowing, it is a variation of concrete itself. So the materials are widely available. So, for example, limestone, clay, and so on. So cement in essentially cement, and after that the fibers, sand and river sand and PP fiber, and of course the superplasticizers and so on. So those are all widely available materials, and they are expected to last for many years. And secondly, the most important aspect is that ECC, as I had already mentioned previously, it exhibits strain hardening behavior, or in other words, tensile ductility, and that helps in avoiding the brittle failures, which is very common in concrete. So in concrete, you just typically have one large crack, and suddenly the specimen fails. But that is not the case in ECC. Also, because of this high tensile ductility, there is the possibility of making jointless ECC pavements, because the stresses are automatically neutralized because of this tensile ductility. And jointless pavements automatically means there will be very low material ingress and also a good riding quality for the vehicles. And in the literature, it has been proven that a typical ECC specimen has much higher durability and resistance to freeze-thaw, shrinkage, etc., than typical concrete. And because of these reasons, it requires very comparatively fewer repairs. In fact, only minor repairs are required throughout the service life. No sort of major rehabilitation is required over the entire service life, and it has been shown that it can go up to a minimum of 40 years without requiring much repair. Of course, then the most important aspect is the cost, which will be discussed later, and that is the objective of the study, one of the objectives of the study. So before that, just a comparison from the material properties perspective between ECC and FRC, FRC or fiber reinforced concrete. So why we are comparing these two is because it is quite clear that asphalt and concrete are way below in mechanical behavior and durability behavior. So the only sort of good competition is FRC. But in FRC also, although it possesses good compressive strength in general, but FRC also has the problem of brittle failure. And that is the one major benefit of ECC over any other sort of non-strain hardening composite. Why that happens is because of the micromechanics based tailoring. There is a whole other field dedicated to that on why ECC is able to exhibit this multiple cracking and sort of strain hardening behavior. And because of that, there is a lot of sustained, stress before the ultimate failure, and there is this allows for sufficient warning before the failure. So, but then ECC also requires a high amount of fibers. The one of the major reasons for this behavior is the high fiber content, which is close to like 2% by volume fraction of PVA fiber. So that causes the cost to increase a lot. So for the Indian context, a sort of a low fiber volume version of ECC has to be employed, and for pavement applications, so that the guidelines are satisfied and also the tensile ductility behavior is retained. And specifically for the Indian context, we have huge amount of traffic and traffic volume, and there is a lot of intermixing of traffic of different sort of like heavy traffic and light traffic, and it causes a lot of failures in the conventional pavements. And having high tensile ductility can help neutralize a lot of those stresses in the pavements. And also one more benefit is that these cracks which appear in ECC are very different from the cracks that appear in concrete. So concrete typically has one large and wide crack, but ECC has multiple cracks, and those individual cracks are very micro cracks. So there is a lesser chance of material ingress. And as our first keynote session speaker, Dr. Kong, was specifying, it also possesses autogeneous self-healing capability. So that is another benefit of ECC. Then the typical mix design which we had chosen for the study was something like this. So it is taken to assume a 28-day compressive strength of 45 MPa, and tensile ductility is taken higher on the higher side. So as you can see, this is quite high in comparison to concrete. Concrete typically has tensile ductility of 0.01% or so. So, and this tensile ductility, we believe, can help in avoiding a lot of these failures. So these are just the initial material costs according to whatever we have assumed. I'm not going into the detail of these calculations. I have just mentioned here over here. Of course, I've just mentioned the material costs, and this is the sort of the final calculation table which we have prepared. The life cycle cost analysis, which includes the material costs, labor costs, and sort of all the maintenance aspects which we have taken from the literature, like how many maintenances are required and what are the maintenance costs and so on. And we have compared an ECC mix and a same grade RCC mix over the life cycle. And by life cycle, I mean we have taken an analysis period of 50 years and just tried to compare the total life cycle cost, including all the repairs and all the labor costs and maintenance, everything. So it per meter cube, it turns out to be 20,000, around 20,000 for RCC and about 14,600 for ECC. And so in conclusion, as we have already discussed, from material properties perspective, it was seen that for the Indian context, a high tensile ductility material will offer a much more durable pavement than conventional concrete and of course asphalt as well. Then the self-healing and tight track width allow for lower material ingress, and using low fiber content is important for the Indian context because there is a huge road network and cost effectiveness is very important. And this particular final life cycle cost is assuming that low fiber content is used in comparison to the typical ECC. And the life cycle cost analysis indicates that there is up to a 30% reduction when compared to RCC payments. But of course, this is over a 50-year analysis period, because in 50 years, the RCC pavement will have to be rehabilitated multiple times, which is not the case with ECC. So if you consider only the initial cost, of course, ECC is much more expensive than RCC. But over the huge period of time, it eventually results in a reduction. But of course, this is a elementary study, and there are many more aspects of life cycle that can be considered, such as the environmental impact and human health impacts, and of course other mixed proportions of ECC, so that even more sustainable mixes are formed, and those can offer even more reduction in the costs and environmental impacts. So these are few of the references we have used, and thank you so much. I'll be happy to answer any questions.
Thank you, Mr. Pranav, for a really good presentation. Anyone in the audience has any question?
Thank you. I have a question, ma'am.
Yes, sir, please go ahead.
What about the durability considerations for this material, sir? Is there anything?
Yes. So in this particular study, we have not looked at the durability aspects. It was just a feasibility study. But there are many papers in the literature you can find out that durability in terms of like freeze, thaw, or acid attack, alkali silica, everything is compared to conventional concrete, it is much higher than, I mean, it is much higher in ECC, the resistance to these attacks.
Right. Okay, sir. Thank you.
Shreyas, I have some questions. First, how do you determine the grade of ECC? Is there a procedure? Have you tested it, or how?
This is so there is one M45 standard ECC mix which has been like proposed in many papers and textbooks also. So that is the one we have taken, and it has M45 like 45 MPa 28-day compressive strength.
All right. So is that what you have compared with concrete M45 concrete
Yes.
grade
Yes.
in terms of cost benefit analysis?
Yes.
Okay. Another thing that I wanted to ask is where you said that the panels or the stretches of ECC can be much longer than concrete, something
Yes.
like that, right?
Yes.
So how feasible are those panels, like construction-wise? Can you actually construct like that length of the road at once for ECC?
I mean, of course, there is some limitation because you cannot go on constructing the pavement for as long as you want.
Yeah.
At one point, we have to stop. But in principle, it is possible to construct more longer ECC pavements than concrete because it will take care of the stresses on its own.
Okay.
There is no need to prepare separate slabs like 1 meter, 3 meter slabs like we do in concrete.
All right. So that way jointless ECC pavement is what you were discussing.
Yes.
Okay. All right. I have that. That's all for my questions. Anyone else has any question related to this study? All right. Thank you, Mr. Shreyas Pranav. You may stop presenting. Is the next presenter Miss Pratibha VS present?
Yes, ma'am.
All right. Please start sharing. Ms. Pratibha will be presenting on utilization of plastic waste as an alternate binder and plastic coated aggregate in interlocking paving blocks. Please go ahead, ma'am.
Good afternoon, one and all present here. Ma'am, my slide is visible. Am I audible, ma'am?
Yes, please go
Yes.
ahead.
So I am Pratibha VS. I'm presenting my paper titled Utilization of Plastic Waste as an Alternate Binder and Plastic Coated Aggregate in the Interlocking Paving Blocks. So these are the contents. So introduction, materials and methodology, mixed design, result and discussion, conclusion and reference. So coming to the introduction, so this study mainly we are incorporating the plastic waste as a binder in the interlocking concrete paving blocks, and also we are replacing the coarse aggregate with the plastic coated aggregate. So why we have used plastic is the plastic waste or accumulation of plastic in the environment is a very big concern, and it is a major problem like plastic waste management. So if we use that waste plastic, or if we incorporate that plastic waste in a pavement construction, maybe in the flexible or maybe in the rigid pavement, so that may be a major help in plastic waste management. And also the interlocking paving blocks, so these are the type of pavement which can be used where the traffic volume is very less, or in the parking areas or footpaths, and also in the residential tracks. So this the advantage of this interlocking paving blocks are they are easily they can we can install that very easily, and the maintenance and repair work is very easy. So and it is highly versatile, durability is very high, and the major objective of this study is to make this interlocking pavement blocks high resistance to abrasion. So that is one of the major objective of this study. So here there are these are the few materials that are used and the methodology of the study. So here the cement, which is OPC 43 grade cement with specific gravity of 3.15 is used, and fine aggregate M sand is used, and coarse aggregate, here we are replacing the coarse aggregate completely with the plastic coated aggregate. So I'll explain how to prepare the plastic coated aggregate. And waste plastic is used as a binder with the replacement varying percentage for the cement. So physical properties of these materials are tested, so the test results will be shown in the next slides. Then mixed design, so M40 grade of concrete is used for the uh, interlocking paving block preparation. So as per IRC 63, so if we are using the interlocking paving blocks in the residential track, so the grade of the concrete preferred is M40. So we have used M40 grade concrete. So then the casting is done again as per IRCSP 63. So the minimum thickness for the paving blocks is preferred of 6 centimeters or 6 to 8 centimeters. Then the after the casting of ICBP, so it is tested for mechanical properties for different curing durations. So 7, 14 and 28 days. So compressive strength, abrasion value, and also the water absorption test are conducted. So these are the few physical properties of the materials used. So the properties of fine aggregate. So we have used M sand. So the size of the fine aggregate is ranging from 4.75 mm to 75 microns seal. So specific gravity is 2.45, fineness modulus is 2.8, and water absorption is 1.76. Here in this table 2, it shows the properties of coarse aggregate, both the raw aggregate and the plastic coated aggregate. So before going to this table, I'll just explain how to or the procedure of preparing the plastic coated aggregate. So first we'll shred the plastic waste making the size less than 4.75, and we have to clean it thoroughly so that all the pollutants will be removed, and it is heated to a temperature of 140 degrees Celsius. So why 140 is the plastic type of plastic used in this study is polyethylene and polypropylene. So these type of plastic will while heating, so they may emit hazardous gases. So the temperature is kept less than 150 degrees Celsius. Then once the plastic is melt, then we will add the coarse aggregate with okay. Then the raw coarse aggregate is added to the melted plastic so that a thin film is formed around the coarse aggregate. So after that, these are the few tests which are conducted on both raw aggregate and plastic coated aggregate. Here is the comparison between the results. So specific gravity of your raw coarse aggregate is 2.61, whereas PCA it is 2.79, and water absorption 2.04 for raw aggregate, whereas it is reduced in the plastic coated aggregate, that is 0.89. So coming to the crushing value and impact value, so the major aim or objective to incorporate plastic coated aggregate in concrete is to make the aggregate more resistance to crushing load and impact load. So here we can see the crushing value and impact value is reduced much more in the plastic coated aggregate, which offers more, which offers
Parallelly,
Mr. Karthik Shastri, please mute.
sorry, ma'am.
which offers more resistance to crushing and impact load. So coming to the properties of waste plastic, so melting point of the plastic is 140 degrees Celsius and density is 0.91 to 0.94 gram per centimeter cube, whereas the tensile strength of the plastic is 0.2 to 0.4 Newton per mm square. So next coming to the mixed design. So as I said, we have used M40 grade concrete. So the water cement ratio is 0.38. So here we have prepared 5 different mix. So P0 in the mixed design, it represents the conventional concrete, whereas P10, that means 10% replacement of plastic waste as a binder to the cement. So whereas P20 is 20% replacement of plastic waste for the cement, and P30 is 30%, and P40 is 40% replacement. And here the fine aggregate content will remain same, whereas plastic coated aggregate is completely, or raw aggregate is completely replaced by PCA. So this is about the mixed design. So next coming to the mechanical properties on the ICBP blocks. So this shows the compressive strength of the concrete block pavement. So the result shows that the compressive strength of the ICBP for 7 days, 14 days, and 28 days curing. So here, with the increase in the plastic percent, there is an increase in the compressive strength. Even though the plastic content is reducing, the compressive strength is increased. So it is increasing by around 40%. So next is abrasion test. So abrasion test we have conducted in 2 different methods. One is by Los Angeles abrasion test, and the second one is surface abrasion test. So in the Los Angeles abrasion test, a cylindrical specimen is used with a height of 100 mm and diameter of 150 mm. So it is tested for 3 different curing duration, that is for 7, 14, and 28 days of curing. So the cylindrical specimen is inserted in the abrasion machine, and it is rotated for around 500 revolutions, and the difference in the weight will give the wear and tear of the material. Whereas surface abrasion test, a beam is used with a size 300 by 125 by 75 mm. Here the abraded circular area will be 82.5 mm, and the load applied will be 98 Newton, and the rotation will be 200 rpm. So this test duration will be around 6 minutes. So I'll show you the test result of abrasion test here. Both the abrasion test, like Los Angeles and surface abrasion test, the results are okay. So here we can see P0 in the mixed proportion, that is a conventional concrete, and P40, that is 40% replacement of cement incorporated with PCA. So the abrasion is very much reduced. We can see the surface abrasion is reduced by around 69% compared to the conventional concrete. So here we can say that with the increase in plastic content as a binder, so the blocks offer more resistance to abrasion. So the last test, that is water absorption test. So here the blocks are casted, and it is the initial weight is taken, and it is soaked in water for 24 hours. So after 24 hours, again the weight, saturated weight of the blocks are taken. Then the difference will give us the water absorption. So here again, with the increase with the percentage of plastic, we can see that there is a reduction in water absorption. So it is reduced by around 25%. So the conclusion is basically, as I said, the main objective of incorporating plastic coated aggregate instead of raw aggregate is to make the aggregate more resistant to impact and crushing, and also the abrasion. So the abrasion value is reduced by 69%. And next, coming to the compressive strength. So with the increase with the plastic content, if I say the ICBP block with 40% of plastic binder will have an increase in 40% compressive strength. So coming to the water absorption, so water absorption is reduced by 78%, and also the abrasion value on the ICBP block. So for the conventional ICBP block, the average abrasion of both the tests, like Los Angeles and surface abrasion, so the average is around 2.9%, whereas the ICBP with PCA and plastic binder of 40%, it offers 2%. So there is a reduction of 69% in the plastic binder. So it is even economical, and we can see the strength parameters and also the abrasion resistance. So it is more helpful by using the plastic waste in the interlocking paving blocks. So these are the references. Thank you.
Thank you, Ms. Pratibha, for a very informative presentation. Anyone has any question? Anyone in the audience? Please ask your question. Ma'am, I have one question.
Yes.
Can you go to the water absorption slide?
Yes, ma'am.
Here, water absorption is lowered. However, my first question is, why is the actual weight is reducing? What is the reason for that?
Actual weight is reducing because the cement content is reducing. So the density of cement is 1.44, whereas the density of plastic waste is 0.99. So as we increasing the plastic content, the weight of the block is also reducing.
Okay. And what is the implication of what reduction in water absorption in terms of concrete pavement? Pavement.
Okay. So water absorption, if the water is or the block is getting saturated, so there may be a chances of stripping of the aggregate or stripping of the materials. So and also it may reduce the strength of your subgrade. So if we reduce the water absorption percentage of ICBP, so strength we can so there will be a increase in strength.
Okay. Any other questions, anyone? All right, thank you, ma'am. You may stop presenting. Is the next presenter Reenu Raju present?
Yes, ma'am.
All right, please start sharing your slides.
Okay.
Also, make sure that you are turning on your video. Reenu Raju will be presenting on numerical study of gap built up lip channel column under eccentric loading. She has written this paper in addition to with Gopika Murthy.
Yes, ma'am.
Ms. Reenu, please start presenting. Please turn on your video as well.
Yes, ma'am. Ma'am, is it visible?
Yes.
Okay. Good afternoon, everybody. So my paper title is Numerical Study of Gapped Built-Up Lip Channel Column Under Eccentric Loading. These are my contents. Moving on to the introduction. The demand for lightweight materials in construction has become very popular due to its flexibility and economical importance. These cold-formed steel members are used for the provision of lightweight, durable, cost-efficient structures, and its usage also optimizes the construction time. The CFS built-up sections are commonly used in structural elements to carry larger loads and over longer spans when a single individual section is insufficient. These built-up columns are commonly used in the construction practice as the system develops high axial strength and result in good structural economy. Um, built-up sections are composed of two or more parallel main components interconnected by the lacings or backed in place. So in case where increased axial capacity is required, gapped built-up sections are used, and the presence of gap in it increases the lateral stability of the structure. And these gapped built-up sections are commonly used in struts in steel trusses and columns in portal frames. So the objectives of the study are to investigate the behavior of these back-to-back gapped built-up CFS specimens under CFS columns under eccentric loading, to study the effect of the parameters such as the link channel spacing, gap width, and slenderness on the performance of the column, and to investigate the influence of the web stiffness. This is the methodology. So moving on to the validation. So this is the journal I have taken for the validation study. And for validation, I have taken two models. One is a short column and the other is a slender column. And the table shows the dimension of the specimens taken for the validation study. Here the boundary condition applied is fixed and the load is applied axially, and these are the material properties. And this is the analysis results. First figure is the total deformation of the short column, and the second one is the total deformation of slender column. These are the results. So here for the two specimens, the error percentage is below 5%, and hence the model gets validated. Moving on to my future study. So the first part of my future study is the analysis of short column under eccentric loading. So this is the cross section of the column taken for the analysis. And as shown in this figure, this gapped built-up column consists of two main channels placed back to back with a gap in between them. And the gap can be formed through the intermediate link channel provided between the webs of this back-to-back channel section. So here the section labeling is such that the DB of 75 indicates back-to-back built-up channel with a gap width of 75 mm. S100 indicates intermediate link channel spacing of 100 mm, and L500 indicates column length of 500 mm. So these are the models of the short column. So here the analysis, a nonlinear analysis was conducted on ANSYS workbench, and these are the models of this short column under eccentric loading. Here the eccentricity varies from 15 mm, 30 mm, and 45 mm. And this is a top view of the loading plate with eccentric load applied on the z-axis. Then these are the total deformation of the short column under different eccentricities, and these are the total deformation of the slender column under different eccentricities. And the table shows the effect of this eccentric load on the ultimate load carrying capacity. Here for short column and slender column, in both cases as eccentricity increases, the ultimate load gets reduced. And two main parameters were studied here. One is intermediate link channel spacing and the other one is gap width. So moving on to the first parameter, that is the effect of intermediate link channel spacing. So intermediate link channel, that is a channel provided in between the gaps of this main channel section. And here the spacing of this intermediate link channel varies from 50, 100 and 150 mm. And these are the models of the short column with varying link channel spacing. And these are the results obtained. That's the total deformation of the short column with varying link channel spacing. And these are the total deformation of slender column with varying link channel spacing. And the results are tabulated here. And here for short column, the gap width remains the same as 75 mm and the link channels varies from 50, 100 and 125 mm. And here, as the link channel spacing increases, the load carrying capacity gets reduced. And in the case of slender column also, the gap width remains the same as 75 mm and only the link channel spacing were varied, that is 425, 475 and 525 mm. Here also, as the link channel spacing increases, the load gets reduced. Next one is the effect of gap width. Gap width is the width of that gap provided in between this main channel section. So here, the gap width varies from 50, 75, 100 and 125 mm. These are the total deformation of the short column with varying gap width, and these are the total deformation of slender column with varying gap width. And the table shows the results of this analysis on this, but with the varying gap width. So in the case of short column, the link channel spacing remains the same as 100 mm and the gap width varies from 50, 75, 100 and 125 mm. And for slender column, link channel spacing remains the same as 475 mm and only the gap width varied. And here also, as the gap width increased, the ultimate load carrying capacity get reduced in the case of short column, and in the case of slender column, as the gap width reduced to 50 mm, there is a considerable increase in load was obtained. That's about 10 kilonewton was obtained as the ultimate load, and after that the load get reduced. Next is the influence of web stiffener on this gap to built-up column. So in order to improve the load carrying capacity of the slender column, web stiffener was provided on this built-up column. So this figure shows the model of this slender column with the web stiffener. And these two figures are the figure showing the column without web stiffener and with the web stiffener. So here the stiffener is provided on the two sides of this in the webs of the column, and here the stiffener of width 10 mm and the depth 15 mm was provided. This is the total deformation of the slender column with the web stiffener. So these are the results obtained. So here for the slender column without web stiffener, the ultimate load obtained was 6.67 kilonewton, and for the slender column with the stiffener, the load obtained was 13.25 kilonewton, and the percentage increase in ultimate load is about 98.65 kilonewton. So moving on to the conclusion. So here, the study was conducted on this gap to built-up column under eccentric loading, and the parameters such as the link channel spacing, gap width, and slenderness were performed, and also the influence of web stiffness was studied. And this analysis research concludes that the eccentricities had a significant influence on the ultimate load carrying capacities of these built-up columns. And the load carrying capacity decreases with the increase in these eccentricity values, and the reduction in link channel spacing improves the load carrying capacity. The maximum load was obtained for a link channel spacing of 50 mm. In the case of a short column, varying gap width does not produce a much improvement in strength, but whereas in the case of slender column, when the gap width reduced to 50 mm, a greater improvement in ultimate load was obtained. That's about a 50% increase in load was obtained. Then providing web stiffener was found to be an effective way of improving the load carrying capacities of this built-up column, and the percentage increase in load for slender column by providing web stiffener was about 98.65%. And these are my references. Thank you.
Thank you, Ms. Reenu Raju, for a very informative presentation. Anyone in the audience has any question for her? Okay, can you show your slides?
Okay.
So this is a study on short and slender columns both, right?
Short and slender column.
All right. And so there are factors that are based on that we can design, and there are some factors which usually are not in our control when the column is being in use, right?
Okay.
So, for example, eccentricity.
Okay, ma'am.
Some of the time, like when we are designing the connection, that way maybe we have control over it. But if there is some load which is unexpected,
Okay.
is there a I wanted to ask, is there a range in which these columns will be usable in terms of eccentricity? Like how we can define for a short column the range in which, if the eccentricity lies, the column is good to use. Otherwise, there may be problems, right?
Okay. Actually, there was not mentioned about the load range. I just conducted an analysis on this. So how
Okay.
much load can carry? That's right.
Just the ultimate load, that's
Yes,
what you have
that's
calculated.
just the ultimate load.
Okay, okay. All right. Anyone else have any other question? Okay, thank you, Ms. Raju. You may
Thank
stop presenting.
Okay.
Is the next presenter Shweta present?
Ma'am, present, ma'am.
All right. Ma'am, please go ahead, start presenting,
Yeah.
sharing your slides. Ms. Shweta will be presenting on dynamic characteristics of sandwich panel with 3D GRF core and FGCNT for reinforced polymer composite face sheets.
Ma'am, am I audible?
Yes, ma'am, you are audible. Please share your slides.
Yeah. My slide is visible, ma'am?
Yes, ma'am.
Yeah. A very good evening to one and all present here. Seeing you back again with a different topic, that is dynamic characteristics of sandwich panel with 3D graphene core and FGCNT reinforced polymer composite face sheets. So the outline of my work: introduction, abstract, advantages, objective, mathematical formulation, results and discussion, and conclusion. So the introduction part. Now the use of composite sandwich panel is being proposed in a large scale, mainly because of its high structural rigidity to low weight. It's being implemented as roof claddings, external walls as in buildings, as well as insulated internal walls of the buildings and cold storages. The ease of transportation and installation is the main advantage of this elements, because it is a readily assembled element, and the construction process is effective and it is faster compared to the conventional way as well. And also the UV protection, long lasting properties, and other thermal insulation properties. The 3D graphene core, the 3D graphene face sheet carries a high strength along with the electrical properties of 2D graphene sheet. There is a vital growth of the invention of 3D graphene structure, which proves it to be an effective material. Now, this paper we have studied the functionally graded carbon nanotube reinforced polymer faces with three-dimensional graphene foam, and I have studied the dynamic properties of this structure as well as the static properties. The equivalent properties of the reinforced carbon nanotube and the 3D graphene foam is being calculated, and the porosity and mass coefficient relationship are calculated from the mechanical properties of 3D graphene. And in this we have used for dynamic properties, we have used the Hamilton's principle here. The third order shear deformation theory is being implemented. The advantages of the sandwich panel: we know it is being used in transportations, bridges, aircrafts, mainly buildings, high speed trains as well, because of its high strength to weight, low weight capacity. And this the objective: the dynamic characteristics of sandwich panel with 3D graphene core and FG CNT reinforced polymer composite. In the mathematical formulation, this is the sandwich panel, and this is the forces that is being acting on the sandwich panel. Here, the initial what is the governing equations of the formulation is here. The displacement field shape for the TSTD is given here, where the UVW is the XY in Z direction, and the polynomial shape function, which is the innovative thing over here. The first order shear deformation theory and sinusoidal shear deformation theory is being used earlier, but here I have used the third order shear deformation theory again for the dynamic property as well. The strain displacement concerned with the stress is being given over here, and the stress relationship is being formulated in a matrix format. The abbreviation used here is 3D graphene and UVP. This UVP is nothing but uniformly varying porosity and non-varying porosity or non-varying porosity surface. Now, here in static analysis, we have used the virtual work principle formula, and for dynamic work, we have used the Hamilton's principle. In Hamilton's principle and in virtual work principle, the only difference here is we have T here, which is something that in Hamilton's principle, the
Ma'am, your slide is not changed. Hello?
Hello? No?
Yes, ma'am. Your slide has not changed. Also, you have a connection problem, so you may switch off your video. That way, we will be able to hear you better.
Okay. Sorry for the trouble caused.
Please share your slides, ma'am.
Ma'am, is the slide visible now?
No, ma'am, it's not appeared yet. Okay, now it's come.
Now it's come. Okay. So that's the Hamilton's principle. And visual kinetic energy. In visual kinetic energy, the basic formula is being used, that is half mv square. That is what is given over here. UVW is nothing but the initial, that is the stress resultance, is being denoted in this way in the dynamic properties. Then the various grading patterns that is being implemented in my study, it is the same as the static study. Here, the first one is UVP, that is uniformly varying 3D graphene core, and the second one is uniformly varying graphene core with non-varying porous core. The core is being varied in this B and C. You can see the difference here. You have bigger bubbles or holes here, and the other side, you can, in the C image, you can see smaller holes. And D and E, you can see the non-varying porous surface. That is, in the surface of the core, there is a variation of the material distribution. Next, the validation study of my research work. I have used the Liu and Lee paper. That is, they have given the vibration response for 0.4 to 0.3 is to 0.01 meter sandwich panel with facing and core properties of 70 and 7 GPa. We all know that the density, the GPa and the Young's modulus properties of graphene core and the CNT is tremendously high. It is terapascals compared to the steel and other metals. So the numerical and analytical results given by Liu and Lee were validated with the present approach what I have done. The validation study proves that all my results go along and they matches well with the numerical and analytical results of the literature. The results and discussion, the free vibration response of the sandwich panel is studied, after which the forced vibration properties is also calculated. And also that the vibration response of FGCNT reinforced polymer foam, a sandwich panel with as a CNT and porosity coefficient is also being shown. Now the analysis is repeated by changing the non-varying porous core porosity. The coefficient is 0.6 and the response is shown in the figure, in the upcoming figure 5A and 5B. This one. This is the response given. And with the comparison between figure 4 and 5, it is noticed that high shifting resonance frequency is observed in figure 4, which is due to the elevation of variance in dynamic stiffness that increases the porosity coefficient as a whole. So in FGX pattern is nothing but V and inverted V pattern. The stiffness, the dynamic stiffness is high compared to the other one. Further, the ratio is reduced to 2 and seeing the grading pattern effect to the response in figure 6. And also with the respect to the earlier discussion, the higher natural frequency is better. It is seen that the lower frequency is observed in FGX and NVPC porous. That is FGV and inverted V with non-varying porous core will not have resonance behavior compared to the other cases. So this is the graph in my resultant discussions. Now, the conclusion of the study, the higher resonance frequency is observed in FGV inverted V non-varying porous core pattern compared to the other cases. The resonance frequency of uniform varying porosity occurs in between the NVPC and NVPS cases. As the porosity coefficient increases, there is an increase in resonance frequency. This is also observed. And for the NVPC pattern, the resonance frequency shifted towards the right when the porosity coefficient decreases the resonance frequency. As this paper presents the characteristics of lightweight composite sandwich panel, the result obtained in the study can be used for the design of the sandwich panel for various applications where lightweight sandwich structures can also be preferred. So these are my references. Thank you.
Thank you, ma'am. Anyone in the audience has any question from this very innovative research work? Okay. Ma'am, the modeling and analysis for this research, have you written a code or where have you done that?
Yes, ma'am. I have written a code, ma'am. Actually, it's not been shown in the PPT, but it's all mathematical formulation is completely dependent on code, ma'am. My co-authors, one of my co-author is well versed in code writing, so we did it together.
All right. So I wanted to know, and
Yeah.
this is a question that I forgot to ask in your previous presentation as well.
Yes, ma'am. It was a static analysis. Yeah.
Right. So so in the sandwich panel, there are two faces, and then in between the material is different, the graphene core.
Yeah.
Right?
Yes. Yes,
So
ma'am.
what is the face material on the faces?
That is FGCNT. That is functionally graded carbon nanotube. That is the face sheets, ma'am. Top and bottom
Okay.
of the sandwich panel is made up of functionally graded carbon nanotubes, which is being graded in 5 different patterns. That is what I showed you, V and inverted V.
Right. So the question I wanted to ask was, how did you account for the contact between the sheets and the core? Like there has to be some sort of
Adhesive.
mechanism,
Yeah.
right? Adhesive.
Yes, ma'am.
So what is the effect of those adhesives and the strength of the material
Yes,
in
ma'am.
a way?
Actually,
And
the matrix that is being used over here is as we use in the epoxy. Generally, we use the adhesive 195 for the experiment or the experimental purpose. We have different kinds of fabrication techniques when it comes to the point of sandwich panel, like vacuum technique or hand delay technique and all that. Now, since I have not got into the experimental technique, we have used the general compression molding technique only. In the matrix properties, we have taken from the literature study. That is what I've given from Liu and Lee. The reference from Liu and Lee, there the properties of matrix is also given. The Young's modulus of the matrix is being implemented inside my mathematical formulation. So when you come to the calculation, even that will be coming together.
okay. So is there a description like in the static analysis as far as I remember, you did a finite element analysis.
Yes, yes, ma'am.
So, I mean, there are contact elements. Did you use those
Yeah,
for that?
ma'am. Actually, in detail, if you have to say, when it comes to the point of sandwich panel, the matrix is the core thing of the study. The matrix and the what component you are using. So definitely the strength depends on the matrix. So the complete calculation what I have bought, the porosity coefficient, the aspect ratio, and all the graph in that the Young's model is in the properties of what you're asking about the matrix. The joining material is given, the implementing is given, the importance is surely given, ma'am. It is in my detailed paper, it is given, ma'am, but I have not shown it in the
Okay.
PPT. Yeah.
Okay, okay. Now, just my thought was that uh, in terms of the dynamic characteristics, you have calculated just the stiffness and I'm guessing mass to calculate the frequency, right?
No, ma'am. I have done displacement, velocity, and frequency. 3 parameters I've done, ma'am.
Okay.
But in this
So,
one, we have
is
shown
there
the
a load,
frequency.
dynamic load that you have applied?
Yes, it's a harmonic load, ma'am. When it comes to the point of static study, we give point load. When it comes to dynamic study, we give harmonic load. That is, harmonic load is a continuous load that you give. That is why it gets vibrating, no?
Right.
Yeah.
Right. So, the
Yes.
harmonic load, how did you apply it to um, the sandwich panel,
Material.
and were there any boundary conditions? Like, did you
Yes,
analyze
ma'am.
it as a beam or
Simply
something else?
no, ma'am. We have analyzed it as a plate only, and the boundary condition is same for the static and the dynamic. It is simply supported boundary condition for both.
Okay, and you analyzed it as a plate or
Yes, ma'am. We
or a
analyzed
beam.
it as a plate. Yeah.
Okay, that's why you also discussed the shape function for that.
Yes, ma'am. Yes.
Okay. All right, thank you. That's all my questions.
Thank
If
you.
there are any other questions from the audience, please ask them.
Yeah.
Okay, thank you, ma'am.
Thank you.
You may stop presenting.
Yes, ma'am.
Now we will call upon the next presenter, Arka Mandal. Are you present in the meeting?
Yes, ma'am, I am present. So good afternoon,
Okay.
and thank you for giving me an
Let me
opportunity.
introduce your topic. So Mr. Arka Mandal has written a paper with Dr. Amiya Kumar Samanta, Mr. Sudipta Ghosh, and the topic is a deep insight into the design methodology of T-beam bridge girders as per the guidelines of IRC 112-2020 compared to the conventional method. So please start presenting and keep your video on.
Is my screen visible?
Yes, sir, please go ahead.
So I will be presenting on behalf of my co-authors. My name is Orko Mandal, and I'm an undergraduate student in the Department of Civil Engineering of National Institute of Technology, Durgapur. So my topic for today's presentation is a deep insight into the design methodology of T-beam bridge girders as per the guidelines of IRC 112-2020 as compared to the conventional method. The paper ID is 250. These are the contents for my presentation. And a brief introduction. So mainly, bridges are defined as a structure that establishes continuity over an obstacle mainly caused due to the presence of a river or a valley. Bridges are a very primitive structure that can be found in nature in the form of a fallen tree trunk over a flowing river, or may be formed due to the collection of rocks and boulders. So nowadays, the concepts of bridge engineering are becoming more and more advanced day by day, resulting in the formation of box girder bridges, arch bridges, cable stayed bridges, and many more. Among all these forms, the most widely used form is the T-beam bridge girders. This form of bridges. The structural design of a bridge is mainly dictated by three factors: the aesthetics, analysis, and planning. Another important point is the practicality or the feasibility for the design, and this mainly depends upon the site conditions, construction criteria, and as previously said, the aesthetics. Previously in India, highway bridges were designed using the working stress method or the allowable stress design as per IRC 21. Later, the limit state method was adapted following the IS 456-2000, which did the job quite well but was not ideally meant for bridges specifically. Then later, in the year of 2011, IRC introduced their code for limit state design, that is the IRC 112-2011, which did contain a much more strict set of guidelines as compared to IS 456. And later in the year 2020, this code was further revised. Now for design methodology, we have mainly two types. That is the ultimate limit state and the serviceability limit state. Basically, limit state refers to that system and combination of loads under which a structure does not give satisfactory results, both in terms of serviceability and strength. So IRC suggests that all sections must be plane before and after bending. The plane of bending must coincide with the principal axis of the element, and strain compatibility for tension as well as compression must be satisfied. So all these provisions are applicable only when the members are elongated and the regions of discontinuity of the member caused either by the variation in geometry or due to the presence of high transverse loading should occur in small portions along the length of the member only. So IRC 112 allows us to use any elastic method for the analysis for slabs, two-way slabs. And the most commonly used method is the Pigot's curve method. Since this method is only applicable for centrally placed loads, for non-central loads, we can use appropriate superposition principles. For the load distribution among the longitudinal girders, the most frequently used method is Corbin's method. However, there are other methods as well, like Henry Jaeger's method or even Guyon's Maisonnet's method. For material properties, we have like IRC permits the highest grade of concrete to be M90 and Fe 600 respectively, both shall conform to IRC 06-2014. The limiting strain for concrete is for up to M60 grade is constrained to 0.0035. Beyond this, the values should be obtained from the given code. Now here we should note that the limiting design yield strain for the reinforcing steel is given by 0.87 Fy by ES, that is the modulus of elasticity for steel, which is less than the value given in IS 456-2000. And this lesser value plays an important role for the design. These are the stress strain curves, simplified stress strain curves given in the IRC code. Now for a sample problem, we have this bridge cross section. Now we need to note that the width of the carriageway is 5 meters. Now mainly what we see that the width of the cross section of bridges are generally more than 5.3 meter, which accommodates all sorts of vehicles like class A, class B simultaneously. But in this case, the width is less than 5.3 meter. So we will have only a class A vehicle accompanied by an UDL, which is 500 kg per meter square. And this case is not frequently encountered in urban areas, but we mostly find this in rural areas or certain places connecting urban and rural areas. Now, as shown in the previous figure, the width of the cross girders are 500 mm, and the deck slab is 2.67 meter by 1.75 meter. And since the aspect ratio is less than 2, it will be treated as a two-way slab. Now, as previously said, the width is less than 5.3 meter, and so it shall be loaded with a UDL of 500 kg per meter square as specified by IRC 6. Now Pigot's moments can be used for the evaluation for the moments for the two-way slabs, and the moment coefficients can be found from the Pigot charts based on the aspect ratios. Now, IRC 6 2017 suggests that there should be a minimum 150 mm gap from the curb of the bridge and the vehicle. But in reality, there is a high chance that this provision will not be followed. In that case, we need to be very cautious and design the curb so that it can take the vehicle load as well in accidental situations. So for that case, the curb should be designed as a cantilever slab. Now, IRC 112 and IS 456 uses the same expression and the same factors, but the breadth of concentration area is different for IRC 112. IRC considers an extra provision by adding twice the thickness of the wearing coat and thus reducing the load, which we can see from table 1. Now figure 3 shows the entire live load arrangement. The left portion is loaded by a class A load and the right side is loaded with a 500 kg per meter square UDL. Now we can see that the resultant of the two loads lie on the opposite side of the center line. So as we can see that the resultant of the two loads lie on the opposite side of the center line of the deck. This gives us a significant advantage such that no girder will receive maximum shears from the two loads simultaneously as evaluated by Corbin's method, since the Corbin's method is dependent upon the direction and magnitude of the eccentricity. Now coming to the computation of absolute maximum longitudinal bending moment. Since the bridge is only 10.5 meter long, it is unable to accommodate an entire class A vehicle, which is 18.5 meter long from axle to axle. So for absolute bending moment, for the computation absolute maximum bending moment, we need to consider a subset of wheels, which is placed in such a way that the midpoint of the CG of the loads and the nearest load, that is the critical load, shall coincide of the center line of the bridge. However, a better approach is proposed by the paper number 11, which is given in the last slide in the references part, which takes account the dead load as well as the impact factor simultaneously. Now computing all the moments and shear forces, what we can see from table 2 is that for a definite section, it is 500 mm by 700 mm and same grade of concrete and steel, IRC 112 gives a better moment of resistance and has a greater value of limiting percentage of steel. So with this, we can see that using IRC 112 over IS 456 would be a better and more efficient approach. Now, we generally determine percentage of steel using a quadratic equation as shown in equation number 2. Now, since this is a quadratic equation, this will evaluate two roots, and there is a high chance that both the roots are real. In many cases, it has been seen that the greater value of the root, which is greater than the limiting percentage of steel, is considered. In that case, the section design is severely over reinforced, and that might cause problems. So we should always perform the limiting percentage of steel check. And coming to the cross girder analysis, so cross girders apparently look like they are continuous beams supported on the longitudinal girders. But due to the lack of proper wall or column support underneath, the cross girders somewhat behave in between a continuous beam and a set of fixed beams. So we don't know, so we are not sure about the exact restraints. So depending upon the geometry and position of the girders, we give weight factors and hence use the method of weighted moments. So in this method of weighted moments, what we do is we plot bending moments for the general load cases. That is for UDL and point loads for two cases separate, continuous as well as for fixed. In that case, depending, as previously said, depending upon the geometry and the stiffness, we assign load factors. So in this case, what we have done is we have given more weightage to the continuous beam part, and we have given less weightage to the continuous part and given more weightage to the fixed beam part, and hence we have computed the final moments, and the designers can, on their own convenience, can change these values. So for conclusions, we have that for one-way slabs subjected to point loads, the applied moment when followed IS 456-2000 gives a greater value than that of IRC 112-2020. The reaction, and for the next we have the reaction factors for the vehicle load and the uniformly distributed live load do not reach its highest value simultaneously for a particular end longitudinal girder. The next is IRC allows a lesser limiting value of strain for steel, thus lowering the depth of the neutral axis of the section. The limiting value of percentage of steel must be taken into consideration while solving quadratic equations as previously mentioned in equation number 2. Now, for the last, we have while computing the weighted moments, the coefficients of positive and negative moments are observed similar for point load, whereas the coefficient of negative moments is almost twice as that of the coefficients for positive moments of the UDL. These are the selected references, the papers, and as previously mentioned, the paper number 11. These are the codes and handbooks used, and these are my co-authors: Dr. Ramya Kumar Samanto, Professor, Department of Civil Engineering, National Institute of Technology, Durgapur, and Mr. Sudipto Ghosh, Research Scholar, Department of Civil Engineering, National Institute of Technology, Durgapur. Thank you.
Thank you, Mr. Mandal, for a very informative presentation. Anyone from the audience has any question, please ask them. All right, Mr. Mandal. As far as I just want a clarification. By conventional method in your title, you mean the design of beams by using IS 456. Is that
IS 456 method, and as well as like for the cross girder, what I have seen mainly in many cases, they either treat the beam as a continuous beam or as fixed beams. So both are included.
All right. So I know there is I can see a comparison, especially a change in the modulus of elasticity or yield strain for steel and
Yield strain, yes.
yield strain for steel. Other than that, can you just very briefly summarize the main difference other than the yield strain? Is that it?
If we consider the yield strain, now that plays the most important role because it changes the strain block. And other than the fact, and other fact is like for the slabs subjected to point loads, as I've showed in the cantilever case, like the width of dispersion of the load, which is more for IRC 112. Since the width is more, what we can say that the pressure will be less, the load will be less. So we will get a much more economic section as compared to that of IS 456-2000.
Okay. All right. Other than that, when you talk about the cross girders, there is always confusion or exact end conditions are not really known. So you did a small study. Do you plan to expand that study to a more include more factors in it, or propose a coefficient for the boundary conditions or something like that?
No, in the future studies, I am looking into finding out a method or something which we can estimate the moment coefficient, the weighted weights in a much more accurate manner. This is done mainly based on the geometry, which is not always correct.
Right.
So yes, exactly that.
So, what you have done currently, are there any assumptions that you have made in
No,
that
both.
study?
No, there is no assumptions. Both are based on the real codes. No assumption from my side is done.
No. I mean, there are always assumptions in the code as well, right?
Yeah, only the assumptions are based upon the code only. Like as I said, the strain deformation for the sections, flexural sections are ignored, but in reality we cannot ignore that, and the loadings are also always not uniform. So
Right.
in that
Okay.
case, we need to consider realistic factors as well.
All right. Thank you for the presentation.
Thank you.
This one we had one presentation left for paper number 218. Kiruthika R is the presenter here. Kiruthika R, presenter and author of paper number 218, Seismic Hazard Assessment of Chennai City using Deterministic Approach. All right, if not, I think we will end the session here. Thank you for all the authors and presenters for presenting your research here. Please join us tomorrow as well for the further sessions. There are keynotes sessions going on currently. Currently, there is a keynote session by Professor Dr. Sandeep Singh from IIT Roorkee. If you are interested, please join that. The keynote sessions will be held up to 6 p.m. So please join those. Hopefully, they will help you all. Thank you, everyone. I will see other presenters tomorrow.
Thank you, ma'am.
So, sir, you may stop the recording for this session.